it's going to look a certain way. And if you have to write Verilog for a finite state machine, it's also going to look a certain way. And it's going to be pretty simple. And if you remember for the project, when I finally put my last version together, the actual code was some parameters, an always block without much in it, and another always block without much in it. So the design is setting up the state table. And that's what Verilog for finite state machines do. So you're always going to see them start. You'll have a clock. You can't have a finite state machine without a clock. You might have a reset, you might not. You might have some other variables, don't know what you're going to have. You're going to have some reg that is going to be the thing that's going to tell you what your next state is. I always called mine state and next state. But here, they're called lowercase y and uppercase y. It doesn't quite tell you what it is, but it's a good clue. If you have a lowercase letter and an uppercase letter, it's probably current state and next state. And then you have some parameters. Those parameters are just shortcuts for your state names. And then you're going to have two always blocks. And the first always block is going to tell you what your next state is and probably what your output is. Your second always block is going to advance your state. I'm going to start with my second always block and make sure that I know what's going on. It says always at negative edge reset in. Negative edge reset in, that is the same as saying reset. The in is not negative edge. It's on the negative edge. That part's not important, but this is the reset. Positive edge clock. So it's saying whenever you press the reset button or you're at the positive edge of the clock, do this. And it says if reset in equals 0, that means if you've pressed reset. So if you see that, that's telling you what the reset is. If you've pressed reset, then your current state is A. So that tells us that A is our reset state. Else, lowercase y becomes uppercase y. This is saying this is our y, lowercase y is our current state, uppercase y is our next state. That's telling us this is a finite state machine. Okay, now let's go back and see what it's saying. Our always block is going to be always at, and we have R, which is some input, and Y, which is our current state, and we're going to check on our current state. So R is our input. And so R can be 0 or R could be 1. It says if R, so if R is 1, our next state is going to be C. This is if we're in A. So if we're in A and R is 1, then our next state is C. Not only that, our output is going to be 0. This tells me whether or not I'm a mealy or a Moore machine. Which am I?
More. The one that does not depend on the inputs.
And this depends on the input because R is our input. It says if R, our output is, so this is mealy. And so this is mealy. And so this would be, our output is 0. Else, so this is if R is 0, else.
And the state is still C, but output is 1.
Output is 1. Whoops.
To the same state, the same next state that has different outputs.
Yep. All right, and now B, if R, if I start in B, if R, Y is A. So I'm starting in B, and if R, Y is A. And what is our T equals 1? Okay, so 1. And else Y is C and T is 1. And if I'm in state C, if R, Y is B. t is 0, else y is a and t is 0. And then, especially because I only had my 3 states, and if I have 3 states, that means I'm using 2 variables. I'm using 0, 1, 0, 0. I absolutely have to have my default. Now, what if I had to go the other way on this? So if I had a state diagram and I had to do the Verilog, so let's say, I'm going to have a real simple one. I don't have a reset. Oh, I should have a reset here. A reset goes to A, and I got that from right here. So I'll put a reset in this one. So your second always block would be identical. Your first always block would be always at whatever your input is, W, and whatever your state is. Ours here was Y. And your case A, begin. This is a more machine. So it's a more machine, so I can start by having my output right here, t equals 1. If W, Y equals A, else Y equals B, end. This is, I should say, case Y, and then B, begin, t equals 0, if W, Y equals A, else Y equals B, end case. And so you just fill in your Verilog, you just look at what your inputs and outputs are, and just fill it in. Do y'all feel like y'all could do that? Why don't I need a default on this one?
You already have all 4 states. Or you need the buffer?
I have 2 states.
Oh, alright.
So
You fill up everything.
my parameter is just 1 variable. I'll try to put this in another video. So I'm going to stop this now. I'll try to post the other videos later tonight. It might be much later tonight, but I will try to do that, and I really like that way.
Got a question. What were you writing there exactly?
Watch the video.
Got it.
Okay.
More